Okay, here I'm going to show you how to do question 5 for this displacement time graph. Alright, how to draw a displacement time graph from a velocity time graph. Okay, from this velocity time graph. Alright, so I'm going to show you here. I broke down the graphs. Right, the first part of the graph is like that. Right, second part of the graph is like that. Third part of the graph is like that. Okay, so there's a easy way to do it. Okay, I'm going to teach you the easy way to do it. Don't worry about the A's. Okay, don't care about it. Okay, I'm going to teach you an easy way to do it. So if the graph is like that, alright, one straight line like that, I know that the area under graph here is positive, right? We discussed this in part A of the question. If the area under graph here is positive, I know my displacement is positive, right? That means my displacement time graph must go from, if I start from here, then I must go to some value more positive. That means somewhere here. Alright, this as opposed to if my area is negative. I'll show you an example. Let's see this area is negative because it's under the zero line for V. Alright, if this area is negative, then when I start here, I'll actually go to some position below. Right, so like that. Can you see this? Alright, so back to this question. If the VT graph is like that, I know that my ST graph will start from here and end up here. But if I start from here and end up here, actually there are three possible shapes. This shape, right? I can curve like that, I can straight line like that, or I can curve like that, right? I call this the half U shape because a U looks like that. Alright, then this is I call the half N shape. Alright, so is it this one, or this one that correspond to this one? Alright, we can sort of guess, right? Because I know that the gradient here is actually the value of the y-axis in this in this graph, right? So you see that value of V keep increasing, right? And the value of V here, which keeps increasing, is the gradient of the displacement time graph. So out of these three, which one the gradient keep on increasing, right? So if you look at this one, you can see that this one is almost flat, right? So almost horizontal means that zero gradient. Then you can see here the gradient is getting a bit higher. It's harder to climb this part, right? So the steepness is getting higher, and the steepness is getting higher, and the steepness is getting higher. So here I know that the gradient is increasing. If I look at this one, the steepness is the same. It's the same difficulty to walk up this part. The steepness is the same difficulty to walk up this part, and the steepness is the same difficulty to walk up this part. Alright, so if the steepness is the same, it means the gradient is the same, right? So it doesn't correspond to this graph over here, right? Because this gradient keep increasing, right? And finally here I have very high gradient because this is very hard to walk up, right? So this high gradient, then it gets better. It's easier to walk up this part. Then here is already approaching horizontal already. So it's steep, less steep, almost nothing, no gradient, right? So this one gradient is actually decreasing. If gradient is decreasing, cannot be this one. So the only one that corresponds to this one is this one, right? And then we can happily do the same idea for this one and this one, right? You can see here the gradient is the velocity is constant. If the velocity is constant, I expect the gradient of my ST graph that represents this velocity time graph to be a constant value as well, right? So again, this is a positive area. Actually, there are three possibilities: this one, and this one. But we already discussed what this is the only one that has constant gradient. So this one must pair with this one. So actually, this one, the ST graph is this one. This one, the ST graph is this one, and this one you can check the gradient is dropping, right? Then the gradient is dropping. The velocity is dropping here, and that means that the gradient of this line must be dropping because the gradient of this line is the velocity, right? So this corresponds to this, this corresponds to this, this corresponds to this, right? Normally, this is what I do in the exam, alright? I sort of like try to figure out, it makes sense, right? Then I'll put the answer as this one, and this one for this one, and this one for this one. So actually, we got the first part of the graph done already. Okay, the negative aspect is the same, right? If I know this is a negative area, I know that I start from here and up here, right? But which one is the corresponding answer? Alright, you can see here it gets the value of V gets higher and higher, which means that the gradient gets steeper and steeper, right? So if we look at this one is easy to walk, steeper, steepest, right? So this one corresponds to this one. If you look at this one, the steepness is the same throughout. So this tells me that velocity is constant throughout, which corresponds to this one, right? This one, the steepness is highest at the start, right? This is the hardest to walk, right? Then as you walk down, it gets less and less steep, right? So less and less steep means the gradient is dropping. The gradient is dropping is this one. Can you see that the velocity magnitude is actually dropping? The velocity's magnitude is the gradient. Okay, can? Right, so with that, now I have all the answers ready. So this one correspond to this one correspond to this one correspond to this. So if you look at the graph here, right, this part correspond to this part, which means the ST graph is like that. Alright, and so on and so forth. The second part is like that, so it looks like that. The third part is like that, so it looks like that. So it's this one, then after that is a straight line up, then it's a curve like that. Alright, then we get this part, right? If you remember the graph, this is part D, right? It looks like that. So this one will follow this part. And then finally, this part is the E part, which comes out like that. So that's why your answer is actually given to be, you can look at the answer lah. Okay, I think I didn't open the answer sheet, but it looks something like that, curve up, just a straight line, then N shape, then and the other half N but a shorter distance, and then a curve like that. Alright, can? Right, why the ship will not pass the boy? This one actually, I think most people understand. If you know how to draw the displacement arrow that we use to explain part 1 and part 2, alright, you should be okay. Right, is there anything else in this question? I don't think so. Yeah, okay, so the answer sheet, alright, refer to the answer sheet.